Okay, the examples get increasingly nasty. Shade set A prime and B. So we need, I'm going to start double shading these. The first thing they're asking for is give us all the numbers that are not in A. So that's the first thing I'm going to do. I'm just going to go around and shade everything that is not a member of set A. Okay, done. Now, they're also asking for set B. So I'm going to shade all of circle B. Now, this region, the darker one, is the region that I shaded twice. This is the only part that satisfies both of these conditions at once. It was in the not A section that covered almost everything, and it's also in circle B. 15 was only covered once. 17, 1, 2, 11, etc. were only covered once. These guys were not covered at all, so these are not satisfying the AND condition. AND means it's got to be both of these things at once, and that means only 5 and 10. So what we shaded there was not A and B. Or in English, we would probably say this as something like B but not A. So you're in circle B, but if you're in A, then that's no good. These guys aren't B, so they're no good. This one is B, but it's also A, so that's no good. He's in the forbidden group, and only these guys are all right. How many members are in that group? 5 and 10. Just two values. Let's see how much worse these can get. A or not B. So they're saying being in set A is all right, or not being in set B. So now I'm avoiding set B and coloring everything else. Let me get all this covered. Okay. Now, there's a difference with this one. This means or, which means you don't have to be colored twice. You don't have to have both of these conditions covered. Either one of them is okay. This is saying if you're in set A, then you're colored blue and you're in. Or if you're not in set B, then you're colored blue and you're in. If you're colored twice, that's great, but it's not necessary. So an AND condition means you've got to be colored every single time. You've got to be in the darkest group. An OR means as long as you're colored at all, even once, then you've met one of the criteria, and that's good enough. So we're going to be counting every number in here except 5 and 10. In English, let's see, this means A or not B. That's the direct translation. A or not B. I'm trying to think if there's a nicer way to say that in English, like the way we did with B but not A. A or not B. There kind of isn't. The only way I can think of to turn this into English that's reasonably compact would be to say anything except B only. If you're in this section, then you're a member of B and you're not a member of anything else. That would make you B only. Here we've colored everything except the B onlys. This is not a great translation. Don't worry. If you don't like this, I agree with you, but it's the only thing I could think of. I'm just trying to show you some other ways that we can say these that don't look like logic symbols. And for how many numbers are we talking about? Well, I'm going to shortcut it. We know there are 19 numbers. Here are 2 that don't qualify, so that means there are 17 which do. Okay, what's next? Not A and not B. So if it's an and, think about what that means with the coloring. We're going to have some sections that are colored not at all, some sections colored light blue, and some colored dark blue because I ran over them twice. And this symbol means it's got to be twice. We have to have areas that are colored by every condition. So not A, looks like. I'm avoiding circle A. And we get all this. Okay, that's not A. Everything except circle A. Now I have to do that again, but this time I avoid circle B. So all the universal set. And I'm sneaking around the edge of rats. Oh, that looks lousy. Sorry, I let up the pressure on the pen just for an instant, and it compromised my coloring job. Okay, well, I think we survived that. Okay, so I colored everything outside A, and then I colored everything outside B. And so, because this is an and up here, we have to get the area that's colored dark blue, the area that's colored twice. That would be everything outside the two circles. This, I apologize for, this should be light, like down here. This entire circle should be light blue. It should look like dark blue, light blue, white, light blue again. And so the area that qualifies is the outside here, which contains 1, 2, 11, 16, 19, and so forth. That's numbers that aren't in A, and they're also not in B. So not A and not B. This one has a nice English translation. English has a perfect word for this, neither. Neither A nor B. Neither Albertans nor Bakers, or whatever you want to think of this as. Neither, well, sorry, in this case they're using the number examples. So these are numbers that are neither multiples of 3 nor multiples of 5. So if you're a multiple of 3, you're kicked out. If you're a multiple of 5, you're kicked out. If you're a multiple of both of them, you're really kicked out. And these are the only numbers that remain. And how many of those are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if I'm counting correctly. Okay, let's see if I can improve my pen control for this one. Shade set, not A. Okie dokie, here it comes. I have shaded everything that is not in circle A. And then we have not in B, so now I have to cover everything that is outside circle B. Here I am going around the edge of it. And then I shade everything else. Everything that's outside circle B is considered not B. There we go. Okay. Same drawing that I should have had over here, except the drawing went nicer this time. Except, here's the difference. This time they're talking about or, the union. That means if you got colored by this, or if you got colored by this, that's good enough. You don't need both. Either one is okay. So, for this one we have not A or not B. They took care of that for us. This one doesn't have a nice English translation. This covers everything except where they overlap, where you have A and B. So this is equivalent to everything except both A and B. This is saying you can belong to this group, or you can belong to this group, or you can belong to neither group. But if you're in both groups, then you're out. That's excessive for whatever reason. And how many members are in this set? I'll shortcut it. The only one that doesn't qualify is the number 15, so 19 take away 1. There are 18 numbers that are out here in the colored blue, and only one that didn't qualify. He missed both of the requirements. Okay, so shade set A and B prime So you remember what happens when you have a negation like this on the outside? This means figure out what this group is, and then the prime says, okay, not those people, everyone but. So I'll do it like this. I'll switch colors for a moment. Okay. We'll find out who this band group is, and then we'll identify everyone outside it. So A and B, because remember, think of that like an and symbol, is just this little section in here. That overlap is the only place where you're in circle A and circle B. So this listing is saying, okay, you know the number in A and B? You're like, yep, got it. The prime says, not that, not them, everyone but. So now you come back and you go, okay, I'll change colors again. Get my blue back. Now you come back to the diagram and you say, okay, everyone here good news, you all qualify, you all get to be colored blue. You get, double touched again. You all get to be blue, you all get to be blue, 5 and 10, you get to be blue. 15, you don't. You're on the banned list. You're the only number, in fact, that got banned by this. Because this said, okay, you know 15, you know the set he belongs to? Not that. So, what we ended up with was not, parentheses, A and B. This one doesn't have a nice English translation. You could say like A or B or neither, but not both, which is really awkward, but luckily logic has a fairly concise way of expressing it. And how many numbers did that cover? Well, 15 got disqualified, all the others were okay, so 19 take away 1. There should be 18 members out here. And last one, shade set A union B prime, or negation. So A union B would mean we start with, here's all the members of A, and here's all the members of B. That's what this inside section means. All the members of A combined with all the members of B. Now the prime says, okay, you got all those people? Not them. Give me everybody else. So, all right, now we go through and we shade everything out here. All this. But we avoid the reds. The reds are banned. They've been identified as undesirables. Crying out loud, I'm bad with the pen this morning. There we go. Okay, so we got everyone who is not in the banned areas. And they're calling that not A or B. In English, again, we have the word neither. Neither A nor B. And how many members are in that set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, if you look back at these, here's some duplication. These two, let's see, where are we here? There's something here they want you to notice. A prime and B prime ended up giving the exact same result as A or B all prime. And this set, A prime or B prime, ended up being the same as A and B all prime. This is something that came up in an earlier example, and this is the time they've chosen to nail it down. What it means is, if you have something in brackets and there's a prime outside it, just like in math, you can take this prime, it's like a negative sign, and distribute it through the brackets, and it changes everything inside. And here's what you get. I'm just going to write this again. We have A and B all prime. So the prime comes in, it hits the A and turns it into an A prime. It hits the B and turns it into a B prime. And here's the thing that doesn't happen in math, but it does happen in logic. The prime hits the and flips it into an or. So when you negate a logical expression, your A's turn into not A's, your B's turn into not B's, that's obvious, but ands turn into ors, and ors turn back into ands. So this says not anything that's in set A and B. This one says things that aren't in A or things that aren't in B. And you can see from the diagrams up there, I'm not going to scroll it around again, but you can see that there were six examples on this page, like so. This one and this one both gave the same result, and this one both gave the same result. This is why. For this second expression, I'll just go through this again. If you had A or B all prime, that's this, the prime goes through and affects all three of these things again. So the A turns into an A prime, the B turns into a B prime, and the or turns into an and. So A or B all prime is equivalent to A prime and B prime.